Okay.
Okay, anything else?
Will we expect to, do you think everything we need to know is in your slides, or is there some things that are in the readings that we don't need to know?
Everything you need to know is either in the slides or I've said it in lecture. It's not that I'm asking things from the readings that I didn't cover in lecture. So basically, if you've been here and if you look through the slides and take some notes, you should be fine. Okay, good. So Sean, let's get started.
All right, thank you, Alex. All right, so today we're going to be chatting about design. Maybe if you guys saw, we aren't going to be going specifically into like web design per se, as the joke there might entail, but we're going to talk about visualization design. And before I get into that, a little briefly about me. I'm Sean McKenna. As Alex mentioned, I'm a fifth-year PhD student. My advisor is Dr. Brian Meyer, and my website's here. And here's some of the previous projects I've worked on. As Alex mentioned, I've worked primarily studying the design process across a variety of things, and that's what my dissertation is focusing on, is how do we design visualizations and what is the process we go about doing that. And that's what this lecture is going to be primarily about. And I've worked in a variety of projects looking at correlation, looking at transit maps, working with cybersecurity, which I'll go through an example of today, and then lately a visual data storytelling project. So that's just a brief summary of some of the things I've explored. You can find out some more information on my website. Feel free to email me if you want to find out anything about any of these. So just as an overview of the lecture, today we're going to first focus on what is design, this introduction, and then I'm going to give you a real-world example using a cybersecurity project that I've worked on. And then we're going to get into a little bit of the theory, talking about first the nested model, which is in your textbook, as well as the design activity framework, which is what I've been trying to study and craft around. And I'll be giving those real-world examples throughout those two theories, so you can kind of get a grounding of what those mean. And then we'll talk briefly about some possible design methods you could consider using in your projects or using in the real world. And then lastly, talk a little bit about what that final project could entail in questions. Are there any questions about what we're going to chat about today? And just to reiterate, I think Alex had mentioned this won't be on the exam, but this is all very design. Like, when you first hear this, what do you think of? Just raise your hand when you have an idea. No one knows what design is? Yes?
Something that solves a problem.
Okay, something that solves a problem. All right. So, good answer. Anyone else have other thoughts? Oh, yeah, let's see you over there.
Creating something new.
Create something new. That's also excellent. Yeah. Any other thoughts? Yeah.
Something that can convey the message correctly and efficiently using some necessary.
Yeah, I mean, communication, those sorts of things can play a role in design. Yes?
Decide how to use the tools that we have.
Sorry, decide how to use?
How to use the tools that we have.
Oh, okay. That could play a role. Yeah, sometimes design is about sort of optimizing things a little bit, about making things work more effectively.
I think of design as not being as absolute as there being one definitive solution to the problem, but maybe there are lots of variations to a solution, but maybe there's some better ones and not as good ones.
Okay. Yeah. I think, yeah, we've heard a lot of good answers so far, and we're going to chat a little bit of aspects of each one of those there. So, just sort of my definition of what design is first it's about creating something new to solve a problem. We already heard that, I think, already. And then it's also, you can use this to make a variety of things. You can make buildings using design, or chairs that you're sitting in now, all the way to user interfaces, which you might build in classes like this one, or say in HCI, human computer interaction. So design is about anything you can think of. And it's used, again, in many different fields, as we mentioned here, whether it's architecture, whether it's HCI. And we have many possible users or tasks that we might want to think about when it comes to design. Specifically for visualization design, we'll focus this. But it's important to think about what design broadly is. So I'm going to briefly go to this excellent video from Bill Hammond, if you haven't seen it. We're going to preview just a very short bit about this, about the design of the soda.
The ingenious design
of the soda beverage.
Aluminum beverage can. Every year, nearly 500 billion of these cans are manufactured. That's about 15,000 per second. So many that we overlook the can's superb engineering. Let's start with why the can is shaped like it is. Why a cylinder? An engineer might like to make a spherical can. It has the smallest surface area for a given volume, and so it uses the least amount of material. And it also has no corners, and so no weak points, because the pressure in the can uniformly stresses the walls. But a sphere is not practical to manufacture, and of course, it'll roll off the table. Also, when packed as closely as possible, only 74% of the total volume is taken up by the product. The other 26% is void space, which goes unused when transporting the cans or in a store display. An engineer could solve this problem by making a cuboid-shaped can. It sits on a table, but it's uncomfortable to hold and awkward to drink from. And while easier to manufacture than a sphere, these edges are weak points and require very thick walls. But the cuboid surpasses the sphere in packing efficiency. It has almost no wasted space, although with the sacrifice of using more surface area to contain the same volume as the sphere. So, to create a can, engineers use a cylinder, which has elements of both shapes. From the top, it's like a sphere, and from the side, it's like a cuboid. A cylinder has a maximum packing factor of about 91%, not as good as the cuboid, but better than the sphere. Most important of all, the cylinder can be rapidly manufactured.
So this is an excellent video that goes into very small details about the soda can design. If you were ever interested, I definitely recommend checking out the rest of this video, including how they created those little pop tabs on the top of them. And very interesting, but the things you might have noticed is there's some engineering reasons why we might choose to build the soda can this way. You know, whether it's about packing efficiency, about being able to move things, how many materials to manufacture. And we think about those maybe more from an engineering standpoint. But there's other factors that you might want to consider as well, as mentioned in this video, like how easy it is to hold, or whether it'll roll off the table. And those are the exact types of things we want to think about when it comes to visualization design as well. Slideshow, 1 second here. All right, so what is design not? So let's go briefly into that. So design is not just about making things pretty. It's not the exact same thing as art. And people do consider that, there's some relation between these two, but art is more about the appreciation of beauty, emotions that you invoke. Something without a clear purpose is not what design is, because design is supposed to achieve something with a purpose. And you want to build something with justification or evidence for why you've gotten to those decisions. There might be some things that are fuzzier than others to justify, but there should still be some justification, some evidence to support what you built. And in design, you hear a lot about this form versus function debate. Commonly what is said, it's form follows function. And the function, say, of this table here on the screen here, maybe we want to make sure 2 people can sit at it and eat. And this table does that. And if your function is to maybe seat more people or be more practical to store things along the whole length of the table, this might not be the right kind of table for you. And so the form that you have will depend on the tasks that you have to achieve. This quote here from Alberto Cairo is really good. The better defined the goals of an artifact, the narrower the variety of the forms that it can adopt. And so it's important to think about this, function first and then the form as we go and build design. And so why does design even matter for visualization? And we can think about this, as Tamara mentions in her book, that there are many ineffective visualization combinations. And we have a lot of users that have unique problems, unique types of tasks that they're trying to handle, and many different types of those tasks. And we have a large design space. And if you don't believe me, here's the taxonomy that Tamara presents in her book. Sort of the what, the why, and the how of visualization. And as we go through and find maybe one of our data columns that has one data type, and find one task for that data type. And then we have many different ways that we can encode or interact with that. Yet we still have all those other data sets and all these other data columns that we have to consider. So it definitely explodes into many possibilities. And we have to make the right decisions and get the right justification for each one of those. And so when should we design? And that's when we get to this idea of what's called wicked problems. And wicked problems are something that has no clear problem definition, where the solutions are either good or bad, not just true or false, but you can say something is good or bad. And there's no clear point to figure out where you should stop with your solution. You could keep incrementing and making it better and better if you wish. And so some examples from this space would be things like, examples of non-wicked problems, or what are sometimes called tame problems, things that have solutions that are true or false when you think about solving a math equation. Or when you're trying to maybe figure out how to win this game of chess in 2 or 3 moves, or maybe figuring out a Sudoku puzzle. And so all of those are non-wicked problems, whereas wicked problems are the opposite. And there's many different examples out there. Does this concept make sense, or do people have some ideas of wicked problems right now?
Are you asking for example?
Yeah, if you have some.
Making your spouse happy?
Yeah, that's an example of a wicked problem, definitely. Anyone else have any quick thoughts? I'll go through some examples here, but so things like social planning, finding out what to do with the economy or policy, those things all have maybe better, good solutions, maybe bad ones, but not really true or false. Same thing when you think of building a car or building toys or the construction of appliances and consumer electronics. All of these things where you might think about design, they play a factor, to what is a wicked problem. Does this concept make sense to people? Yeah.
Just anytime humans are involved, it's a wicked problem.
Very commonly, yes, but there could still be true or false, depending. An example would be, say, if you're running a machine learning algorithm and all your task is to find that query, find that solution, and it's true or false, then that isn't a wicked problem. But once you get into the fuzzier side and you aren't sure what you're looking for, the task gets a little bit more unique, then that might be where you might need, this might be a wicked problem, and you could use design to help solve it. Does that answer your question?
Yeah.
And so design covers many other fields here as well. So we see design being mentioned, obviously user-centered design, human-centered design, these terms are in other communities as well, and they have their own community, as well as in engineering and architecture, human-computer interaction, human-machine or human-robot interaction. All of these you might see aspects of design, and these principles might apply elsewhere. So just keep that in mind when you're thinking about what I'm talking about today and in other classrooms. A lot of this might apply, but our focus is on visualization. And then lastly, when it comes to design, there's sort of 2 main approaches that you can go through and do design. The first is problem-driven. And here is this top-down approach where you want to first identify some problem that's maybe encountered by users that are doing something in the world, and then design a solution to help them work more effectively to solve that problem. And this is sometimes called in our field a design study, but there's other types of things as well for problem-driven work, and it's one huge focus. But there's another focus called technique-driven work. And this is a bottom-up approach. And this is more about inventing new encoding idioms and interaction idioms and algorithms as well. And you can think about classifying or comparing what you've discovered to existing algorithms to encodings and interactions. And so this technique-driven approach is also some way that you can design things, and it is a very different style of approach. And you'll see that with a lot of the papers in the field, that there's often a focus for more technique-driven work and a focus that's different for problem-driven work. And so in that vein, I'm going to talk about a real-world example that I've worked on with some of my projects. And this is in the field of cybersecurity. And so in this real-world project, I'm going to kind of refer to this throughout the lecture with this little sort of icon lock symbol. So if you ever want to look back, you can sort of separate out the theory from the real-world application of some of these concepts that I've worked with. Let's roll back the clocks to November of 2014. Sony Pictures was still a company, and what they were trying to do is, they make movies. It's one of the big things that they do. They work with a variety of studios, and they publish movies through their studio. And what they found in November of 2014 is that malware was discovered on their computers, and it erased about half of all of their work computers and servers. All their data, all of it was getting erased. About 4,000 machines were knocked down around that date. And they were back to using fax machines and handwritten notes in their office. And it took them about 4 months to get all those computers back up and working. And they were uncertain around, why this happened. They knew someone had hacked into their network, potentially North Korea, but there's no proof of the claim. And they had collected information on Sony Pictures over time. About 170,000 emails were leaked out from their network, along with things like movie scripts, salaries of actors and actresses, social security numbers of their employees, passport info, a whole variety of information. And how could this have been prevented? This is the image that appeared on all of those 4,000 machines that they were hacked by the Guardians of Peace. And how do we prevent something like this from happening to our own computer networks, to our own computers, to our own data? And it's really hard to protect our computer systems. And there's a lot of people trying to study why that is. And so again, to what cybersecurity is about is there's a lot of analysts that are trying to protect our networks against attacks such as this one. or maybe information is disclosed to someone you don't want that, or theft of information, or denial of service where you can't get access to something that you should normally be able to access, like your email or your website. And this is really hard because, one, there's lots and lots of data. Every one of your computers that you have open here right now, or your phones, are sending data to and across the university network services, or to your provider for your service if you have, say, your Wi-Fi. And, you know, from all that data, we have human interpreters trying to understand what's going on, because what's usually happening is that there's humans actually performing these attacks. And so they know how to hide, they know how to avoid getting found. And so these attacks are very robust and tricky for people to try and stop. So that's why we have analysts that work to try and stop them. And so I'm going to focus now on a cybersecurity data set that I've worked with very closely. These are called intrusion detection system data, or really what it does is it captures alerts on your network. So when you're, say, sending a lot of data to and from, some of that might look suspicious. There's maybe some patterns that we can say, you know, this is something that might be dangerous. And we flag that. And each one of those flags here is a row in our data set. And so these alerts that get triggered by these rules, they might hint at some potential incident on our network. So an analyst will have to go through and look at this data. And it usually requires some knowledge about our network to understand what's going on. And so we're going to first perform a brief exercise here. I'll ask some questions first. So for each one of these columns, I'm just going to briefly explain what these are. So each item in our data set, each row, is an alert in this IDS system. And these attributes are across our different columns. And so for these different columns, the first column we have is about time, so some date timestamp. And then from there we have an ID for the alert that just is sort of a unique identifier for each alert. And then we have a name for that alert as well, which will be recognized by the analyst, but you might not recognize them here. And then we have an origin and an origin location. So the origin basically represents some computer. These are called IP addresses. They're represented in numerical form, but all it is a unique computer. And that talks to some other computer, like say it's your phone talking to some server, you know, over in North Korea. And in that case, then the origin location, say if you're sending the signal, your phone or your IP address would be here in Utah, and then the destination would be that North Korea IP address in North Korea. And then lastly, there's a class of the alert, and that's just some identifier for maybe it being a detected alert, so it thinks something actually happened, or maybe a potential type of alert, or maybe some other classification. So for each of those, I'm just going to ask you guys, what are some of the attribute types that you would sort of classify these? This is good practice for your exam. So for the first column, for time, who could tell me what the attribute type is? Do you guys need hints on what the attribute types are? A yes or no? Anyone? Yes? So the three different attribute types that you could have are categorical, ordinal, or quantitative. So does anyone know what the first column would be?
Yeah, quantitative.
Yep, I heard it was quantitative.
I was just trying to decide if it was ratio or
Yep,
interval.
that is correct. So what we could do with time is we could say, the difference between these two alerts is maybe of some importance, and you can measure that, and that's comparable to a difference between another two sets of alerts. How about the next column, the ID? Yep, that is correct. It potentially could be ordinal if there was some importance measure there, but it is just categorical. That is correct. And the name? That is correct as well, yeah. The name means nothing except for some category of the data, which is important to the analysts. How about the origin? Each computer is kind of unique from another computer, so that's a good way to think about it. And how about the origin location? Can I hear from someone new? This side of the room's been kind of quiet. Anyone over here?
Would it be categorical?
That is correct, yeah, another category. Now, there might be some additional information here, like here we have, say, both a city and a state, or in some cases, a city and a country. And so there's some additional information there. And then the destination and destination location, those are both the same as the origin and origin location, both categorical. And then lastly, the class. Yeah, another categorical attribute type. So there's a lot of categories in this data set. So now I'm going to take a brief exercise, and I want you guys to brainstorm what are some types of encoding we could use for this sort of tabular data set. And so just, pick a partner, someone next to you, or find someone and just chat for 2 minutes. Think about ways to encode this data. Try and think of different ways. There might be more than one type. And as a hint, think of what type of data this is actually representing. How many different data sets could you potentially represent it as? And there isn't necessarily a correct answer. So just take 2 minutes and chat with the partner.
I would say map seems fairly obvious. And then size a circle, the count of events that will originate from that location. I would also somewhat categorize one of the IP addresses, at least flag whether it's class A, B, C, or network. Get an idea of the types of IP addresses. There's more information than just an address. It's more than just a label. Or even something, something even more like a frequency analysis. There's some prevalence of certain I'm assuming that there are more instances than just the 5 events we have up here. So just if you have hundreds of thousands, then you can get some meaningful data out of some kind of time series analysis. Maybe even a path between origin and destination. To see if there's patterns.
Right, if you guys could start wrapping up those thoughts. All right, would you guys like to share what some of your partners and you guys have talked about as potential encodings for the data set here? Any volunteers? Others like just calling people? Yeah.
We think we can use a map first to locate all the regions and the destinations, and we use links to link the origin and the destination.
Okay.
As a directory, and we use colors to classify like the class. And because other kind of like ID, we don't know what does it mean.
Right.
IP is hard to interpret.
Yeah, and there's a lot of categories for those, so you wouldn't necessarily be able to use color as easily as maybe, say, for the class. Is that correct? Did anyone else have similar thoughts along a map line or other thoughts that you want to share?
In addition to that, if it's interactive, we could have like a spider for the time.
Yeah. Yeah, and what would you do to show the time?
So it's like you have like a minute max, and whatever that is in scale.
Okay, so just like a filter window. Okay. Yeah.
We had talked about, I'm not sure how to integrate it into like a main visualization, but showing all of the events filtered by whatever, by location, by an of malicious activity.
Yeah. Okay. Yeah.
We can also use shapes to distinguish between origin and destination.
Sorry, shapes?
Yeah.
Okay. So what do you mean by shape?
For example, triangles for origin and a square for the...
Oh, I see what you mean. Okay, yeah. So you can sort of uniquely
on the map,
identify
yeah.
the type of map. Yeah. Yeah. Any other thoughts on map stuff? Or does anyone have any other type of encodings they thought of?
You could at least break down the IP address and into class of network. But, that's important information. It's coming from an A, B, C, or D network.
Yeah, so just to clarify for those who might not know everything about IP addresses, there's sort of 4 different numbers here, I think A, B, C, and D. And like at the A level, there's certain types of networks, and then B, there's other types of networks. And even groups of locations are somewhat correlated with, say, like all the A, where A equals 128, might be a certain class of networks in maybe this country or in this area of the world. It is a little bit more complex than just that, but in a rough sense, you might be able to create a visualization based on that concept. Yeah. So is that all the types of encoding people talked about with their partners?
You could have like a graph of with different nodes either being different locations or IP addresses, and then have like the proximity of the nodes be like how many times maybe that same origin to that same destination, something like that.
Yeah, there's definitely a lot of potential possibilities with network graph algorithms, because you can seed almost anything in the algorithm, whether it's the initial position, the length of those nodes. Yeah. There was a hand back there. Yeah.
It looks like there are multiple things originating at the same IP address or multiple things ending at the same destination. So you can have a plot against time and number of hits for a given destination. If there's significant number.
Right. Yeah, and that's what's kind of tricky with this data set is, imagine too, this is maybe just a small snapshot. Like, there's instead millions upon millions of these rows, if not more. So then it would get a little bit trickier. But if there are nodes, certain IP addresses or computers that are getting a lot of information, getting a lot of alerts on them, that might be interesting. But it might even be the case that a single alert, between 2 computers that maybe almost never talk to each other or never have any other alerts, that could also be interesting. But yeah.
Like a sort of two-sided tree diagram, I guess, of what's going to what. So it's more of a notional graph. It's not physical location based.
Yeah, definitely. Any other thoughts? I'll briefly go through some of the examples I've had and seen in the field. You guys have mentioned quite a few. That's a really good job. And so like we talked about network graphs. Another option too is to think about this as time series data, because all of this is happening over time. You could visualize the information differently. Rather than just having a filter window, you could actually say visualize maybe how alerts are occurring over time or when they are occurring. And time itself is sort of an interesting factor to it. So hierarchy visualization can play a role here as well. There's many different types of ways to show hierarchy in different visualizations. But we have hierarchy both in terms of time, because we say have like maybe every day or every week or every hour or second, something might be occurring frequently. Or also by location, because whether it's a city or a country or a state, there's some hierarchy of maybe the location as well that could potentially be interesting. Maybe if a state actor is involved or a certain set of computers. And then along with that, we talk about map visualizations, or you could even just imagine some basic bar or line charts to try and show different aspects of this data. And then the question now is, well, what do users actually use when they look at this data? And a lot of analysts, cybersecurity analysts in the real world, tend to look at data like this in a raw text file. And so, be that as it may, they're really good at seeing that raw data and understanding what that means and going through it very quickly. Whereas visualization might take time for them to import their data into this tool and try to understand how you encode it, to then figure out how they can read their data and do it as efficiently as they do it with raw text files. And that's a big challenge in this space. And so I've worked with a couple different users. One was an analyst here on campus that studies the data that's going across the networks. And I've also worked with analysts and various other users at the MIT Lincoln Laboratory and other government sites to try and understand, again, what these users do and how we can help them do their job more effectively. And so I've conducted a variety of interviews and observations with these different individuals. And what we found overall is that analysts find anomalies in these data streams, like those files that I just showed you, to try and protect these networks. And for one user that we chatted with, he said that his main bottleneck was actually the hard drive read times on his computer. Because he can pull up those data files as fast as the hard drive does and analyze them just about as fast. Whether he's as confident of that as he actually is maybe another point, but he's that confident. And dashboards is another thing we tried to study in this space because they play an important role. As one analyst told us, pictures are great when you're going up to management because you often have 60 seconds or less to make your case. And so we were really trying to understand how do we communicate the cyber information. And so when working with these users, we worked on this personas design method, where a persona is some document that allows you to foster communication within a design team. You sort of have a representative or archetype of the users, their behavior, and their knowledge. And we built these personas through all these interviews and looking at the research that's out there to try and understand what are the big types of users in this space. And we found 4 main types of personas: a cyber analyst, a manager of those analysts, the director of sort of like information technology, and then a CEO of the company. And these were all specific. We focused this personas process on how do we build a cybersecurity dashboard to help people understand and communicate their data to people along for all these 4 types of personas. And so here are those 4 personas up on the screen. I'm just going to kind of walk through more what the analyst is about because that's kind of been the focus, what we chatted about, and that's a primary driver for some of this project. Where analysts here, they gather information for all these other personas along the chain, for all these other people that you might interact with. And their goal really is to try and find that anomalous network behavior, where anomalies could be a single alert that is causing us a problem, or it could be many types of alerts in bulk, a lot of them going on. And they have a variety of information, such as like they know a lot about the cyberspace, but they don't know as much about what the company does as a whole. They don't know necessarily whether machine A is more important than machine B, because they don't make those sorts of decisions. Those often happen at a higher level than the cyber analyst. And they have a lot of questions they're trying to understand about where they should be understanding the space. And what we did when working with these different users, talking with them, is we were trying to find a focus for this project. Try and decide, which types of users should we focus on. And we focused decidedly on sort of the cyber analyst and the manager. So we would have direct access to this raw data, but also how do we start to abstract some of that information away to a user who doesn't always know what the raw data means or what a specific IP address represents. Whereas the analyst almost always know, like this IP address is this machine on this network, and I know that. And so this focus allowed us to build a research tool, this sort of cybersecurity dashboard that I'm going to show you here now. And there's 5 main views to this dashboard, and I'll walk through each one. This first view is a location view, as we chatted about briefly, a map. And for this map view, we have a specific encoding, a Dorling cartogram. I'll get a little bit more into that later. And here we have the number of alerts, is the size of each of these countries here in this data set, and then how more or less than the average it is occurring is in this red to blue scale. So if, say, the United States here is getting about the average number of alerts, it's like a yellow, versus we have some countries over here on the eastern side of the world that are more red, which means we're getting more alerts than average. So smaller doesn't necessarily mean it's red, it's just that they have more than their typical number of alerts there. And then some of those blue countries you might see sprinkled around, they have fewer alerts than normal. And so this average, you can imagine that being a variety of things. You could customize that, pick that, have that automatically driven by a certain characteristic. And then that is this main view. And there's I'll go through some of the details of this encoding later, but there's some drawbacks, but we added a lot of interactions to this dashboard, which I'll show in a video after this. And so the other main view here is a temporal view. There's a couple different temporal views. At the top of this view, there is a bar chart, which encodes for each day how many alerts occurred. And then for any given selection, you'll see a smaller gray bar, which represents for, say, like the selected country, how many alerts within that total are there. And then it's also broken down in this heat map by hour as well as by day. So the day here is each column, and then the hours from the beginning of the day at midnight all the way down to the end of the day, 11 p.m. here at the bottom. And then red is more alerts, so you can kind of get a sense of the temporal patterns really quickly with this heat map. And then we also have attribute bullet charts up at the top of this dashboard. And here again it represents the total number of alerts, and then if there's a smaller gray bar, it means there's a subset. So sort of for the specific country we've selected here, that's the number of alerts within those sort of categories or classes of alerts is what we talked about earlier, as well as the total number of alerts in the bar chart representation. And we also have the details, so sort of that row information for each of those alerts is listed at the bottom. With sort of the total number of alerts that occurred there and some additional information, which is critical for the analysts to be able to go back to the data and understand what's going on. And then lastly, we had sort of an overview to be able to highlight, again, what the selection was, whether you were selecting a certain country, the whole world, the number of alerts in an actual raw number form, so you could get those actual details without having to figure out from that circle radius size, well, what is the number? So that was kind of critical to be able to figure out what your selection is. And so I'll briefly go through a video of that here, just to kind of show you what this dashboard and some of the interactions look like. So when you first load up the map, it starts with this dashboard. It first starts with selecting the whole world, and then you can there see like what the patterns of alerts are across our entire network. And just to reiterate here with the map view, we're focusing where a lot of networks, when we first select something, like when we first gather this data set, everyone is talking to our network. So there's sort of like one really massive data point wherever your network is located. So if it's only located here at the University of Utah, there'd be a massive bubble at Utah. So what we're doing now is instead looking, who are we talking to around the world, and let's encode that information. So it's sort of ignoring one half of the data to focus on who are we talking to. And then here we can select any one of those days here at the top left is what's going on there. Look that up there. And as we hover over each of those bar charts for the day, it'll update the map according to the daily information that you're interacting with. So there's sort of a hover on demand to be able to do this interaction. And then if you want to lock in any of your selections, you can just click on it. So we'll skip ahead here. And so you can also do those similar interactions along those top bullet charts that we have, where you can again hover over each one of those to update the map with that information, or select it again to lock it into place. And the map animation, or the map visualization animates to kind of show the change across those two views, and you can hover back off and forward two different things to be able to compare quickly what maybe two values are, or how the map changes between either two times or two types of alerts. And that's not the best way to compare, but it's a way to easily compare within this particular encoding. And what we found when doing this is that it was also important to have this additional view here at the bottom, there, where you can click on the specific alerts that you've selected and see that what those details are. So you could go look that up in your log files and find more information about that. And you can see for say this particular set that we have like a certain pattern that jumps out at us here. It's sort of like on the heat map there, this little speckled pattern of where certain alerts are occurring, particularly higher than average. And we found that when giving this to users, is there were some interesting things in their data that they didn't know about, that they weren't prepared to see, and that they saw using our dashboard here. Are there any questions about the sort of dashboard and this project that I chatted briefly about? We'll come back to it all, but I just want to see if there's any questions about what I have. Yes?
So you designed this to be used by actual analysts in the field?
Yeah, as well as managers, sort of as a way to help communicate information.
How long did you notice or did you observe it to take to have that person understand how to use the actual chart, the dashboard?
Yeah, so is it okay if I push that off and talk about that later?
Yeah.
Yeah, so I'll get to that once I talk about a study that we performed. So, yeah. All right. So now let's take a step back and let's look at some of the theory behind the design process. And here we're going to talk about the nested model. And the nested model, which is discussed in your book by Tamara Munsner, is sort of the purpose of the nested model is for capturing design decisions. Thinking about what is the justification behind your design. I'm going to give some examples of this project that I just chatted about and how we justify that design. And it's also important to be able to analyze certain aspects of the design process, to break apart into sort of these four concerns, the levels of the nested model, to help figure out which decisions are maybe about one thing versus decisions that are about another, and evaluate them separately. And that evaluation or validation is something that's also, she promotes, is happening early and often. And you definitely want to make the right decisions so you avoid making ineffective solutions. So the levels of the nested model, there's 4 different levels here. There's the top level of the domain situation. So that's like the problem that we're trying to tackle. And then there's the data and task abstraction, which is starting to think about how can we apply that problem sort of generally when we think about the types of data and the types of tasks that people work with. And then there's the idioms, the visual encodings, and the interactions that you use within the, your tool, the system that you're trying to build. How you create the visualizations and then how you interact with them. And then lastly, that how part more is like the algorithm. How do you actually get it to build that visualization, to analyze the data, to get the results that you want. And the algorithm level is very important for technique-driven work. And we've talked a lot about problem-driven work, where you maybe start from this nested model and go inwards. But there also can be technique-driven work, where maybe you start finding a new algorithm, and then think about how that applies to other problems, and write a paper potentially that way. And so for the domain characterization, this is all about finding out what are the details of some application domain. And here you want to think about what group of users are you trying to work with, and what is their target domain. Whether it's like biologists or cybersecurity analysts, or just a general person who maybe would use a visualization system. And then think about what their questions are, what tasks they try to achieve, what is the data that they're trying to work with. And this can vary widely depending on the domain, what the task is and what the data could be. And so you have to be specific enough to continue with sort of the nested model here. You have to know what exactly you're focusing on, what specific data set you want to work with. And that's important for your projects too. You need to find what these questions and data sets are. And what's also tricky about this is you often can't just ask, what do you do in your job? Because people thinking about what they do is very hard for them to answer. If I just went to a cyber analyst and told me to tell them what they do for their job, they'll tell me one thing, versus if I come in with like a specific set of questions and then ask questions based on their responses to try and figure out what they actually mean or what they actually do. That really helps to understand what people do and then how you can help them do it more effectively. Because sometimes what they think is effective maybe isn't that effective, or isn't really the best visualization. Maybe they can find a better way to do it.
I'm guessing that meant that you had to do your homework to go in, so you probably knew about the domain ahead of time before actually going to talk with them.
Yeah, it definitely helps when you're doing problem-driven work to understand the domain. It can be tricky. There are people that will put themselves working in this domain to try and better understand what it's about, and that can take weeks to months to even years to really get a grip on the problem. I've been working with cybersecurity data for probably 3 years now or so, and I still don't understand the space as well as other people do. So it's definitely a challenge and something that takes a little bit of work. But you can still, create visualizations, create systems to help people, even when you don't know as much about the domain. But it really helps to know a little bit so that you can figure out what their needs are. And so what domain characterization was, in the sense of this cybersecurity dashboard project that I talked about, is that one thing I had to do is I read a lot of different papers in this field to really understand what is the type of cyber data that these folks work with, and then what are their needs for communicating that information, and what has been studied in the field to see, because there's a lot of people that have studied cyber analysts, studied how they work with their data, and then different types of users that they work with. So we had to incorporate all that information in our design process. And then conducted the interviews and observations, as I said, to kind of sit through and look at how people interact with these systems that they have, and what types of things that they need to complete and fulfill with their data sets. And that's where we created these personas to try and identify target users. We created this sort of 4 different personas, but then picked 2 to target more specifically. And so that was some of the decisions we made at this domain characterization level to understand, how do people communicate the cyber data? And then, from that task, what are sorts of abstractions we need to make? And that's the next level here, is the data and task abstraction. And you can think of this in Tamara Munzer's model, sort of the what and the why, where you map these into more generalized terms rather than the specific domain tasks that maybe someone's trying to achieve. So rather than just communicate cyber information, it's more about communicating information generally. And it's also important to identify the tasks that the users want to perform or already perform. And again, in more of the abstract sense. And the abstraction is one of the hardest parts to really get a grip with and understand in visualization. So don't fret if you have a hard time understanding that. And even as an expert, as someone who spent years working on abstractions, writing these in papers, this is usually one of the hardest parts. You usually don't even get a good abstraction or task abstraction, data abstraction, until often the end of a project. When you realize wow, this is the right thing, this is what we did. We made all these decisions, and it's really tough to nail down the decisions here. But it's important to do so, to find what types of data types or data sets you should work with, and find the model for your data. And sometimes you have to take the data set that's given to you and transform it in some way. So an example there is, say, the data set we looked at earlier with each one of those rows and those alerts that we had, is that we were looking at, effectively, we had 2 nodes, an origin and a destination, and each one of those was a computer. And as we mentioned before, we could have a network graph And that network graph would maybe be a collection of alerts that occur for maybe one of those types of computers. And that is then a transformation of our data set from sort of this tabular form to instead having the item be a specific computer, whether it's an origin or a destination. And that transformation will help you figure out what types of encodings are available. But this variation and how you guide, how you create these abstractions will really depend on your task, on what you're trying to achieve, what your users want to do. So for my dashboard project, we again were trying to look at this idea, this task of communication. And specifically what we were trying to figure out is how the analysts discover and present patterns. And these patterns were the really important thing that we found. So patterns here are a collection of network alerts that represent some recurring or abnormal behavior. So recurring in the sense that there could be a lot of them happening, or abnormal because it could even be just a single alert. And then for these patterns, we found that we must be able to first identify the patterns within this dashboard, because otherwise if there's no patterns, we can't convey them. But that also comparison of patterns could also be useful. And one way we found to do that identification and comparison of patterns was aggregation of the data, where we would say collect the records that we have, sort of these alerts, by first location on the internet, those computers, and then also by day and by hour, so you can show sort of a temporal pattern as well. And so here's some examples of these temporal patterns that I mentioned, sort of this speckled heat map, but then also this heat map over here, where we found one particular country, there were certain wave of alerts that were always occurring at certain times. And this is actually a really good potential behavior of maybe some automated system, something that's set up to maybe try and scan our network or attack us regularly every day to see, hey, if you're not protected today, I'm going to get in, and we'll keep trying. And so there were a lot of patterns that we found that were very interesting. And then again, the question now is if we know what these patterns are, what our task is, what the data is about, we have to be able to encode that data as well as figure out interactions with it. And so in this space, we have the design of the idioms that will specify some approach. And so this could be both, these idioms are both visual encoding, some visualization, as well as the interactions that you have on top of that visualization. And this is a way to create and manipulate the visual representation of your data. So that creation, that first step, is going to be about the visual encoding, and then that manipulation really is the interaction that the user will perform. And the decisions that you make here are often kind of separate. If you have multiple views, you might make some decisions in one view for this certain type of encoding, but they can be intertwined, or maybe you'll have one interaction, a selection in one view that will affect another view. And the principles of visual perception and memory that you guys have talked about in this course, those can really drive some of the decisions you need to make here. To say whether you want to pick this type of encoding versus this other type, there might be good reasons to pick that, or which color map to use even. There's things you've talked about in this course. And so for the dashboard project that we worked on, we had this location view that I'll talk a little bit about the encoding and interaction there. And we had sort of this, we came up with this map view as a way to show novel patterns, specifically on a country level. And we did this because we talked with users and found out that this was interesting, something that they didn't normally see in their data. Especially when looking at it in just tabular text form, they didn't see that. And we chose the Dorling cartogram as a way to abstract and not have it just be about the map, but rather to have individual bullet points be what was represented there. And we considered other encodings as well, which I'll come back to. And we encoded here the quantity with the size and the deviation from average with color. And we did that because we didn't want to wanted to have the primary channel here really be the location, because people knew where countries were. They wanted to be able to find that right away. And that interaction could help mitigate some of the downsides of using this encoding. Because obviously choosing size of the radial position is not great. And additionally, there was a log scale for that, so it was even worse. But by just interacting with any of these points, you could easily see what the actual values were at each point. And the log scale enabled us to see a single alert, which was just as important sometimes as group alerts. So we had to make sure that those were all visible. But that you could always differentiate between groups, sort of sets of large alerts or smaller alerts based on the size still. And then this also enticed users with this interaction to dig into additional detail views by sort of forcing them to find those details by interaction. And sometimes that's not always the best thing to do, but interactions can really add a lot of interesting bits to your visualizations and your systems that you build. And so lastly, the inner level is on the algorithm. And so this is something about instantiating some algorithm computationally. It's sort of the innermost level of our model. It's what drives those encodings and those interactions, what makes everything work. And so this must efficiently handle all of the design encodings, all of the interactions that you've chosen, because if it doesn't handle this efficiently, the system's going to be slow. Users won't want to use it, and that's not good. So it needs to be interactive. And there might be different definitions of what interactive will mean in certain contexts, so it's important to keep that in mind. Because maybe clicking on a button, a user won't mind waiting 5 seconds if their current workflow would take them an hour to get the data. But if it takes them 5 seconds and their current tool is faster, then maybe you won't get them to use your tool. And so there's other factors here to think about as well as not just computational time, but how much memory something takes up to maybe keep all the data there. And also exactness, or how much uncertainty is in the data that you show the users. And it's usually best to try and strive for a fast enough response, something that gives you interactive frame rates. Because if you make it, say, a faster algorithm, but the user doesn't really notice that, doesn't see any difference in the system, then it might not really matter that it's faster. Now there might be some context, maybe larger data sets or certain types of older computers that might help with. So there's a lot of factors that you have to be wary of. But this is really sort of some of the fundamentals of computer science. When we think about making things faster is typically better, but not always. And so for my project that we worked with, there was another type of encoding that we considered here. This was using a tree map rather than a map-based view. Now, have you guys talked about tree maps in the course?
No.
No? Okay. So a tree map is some sort of hierarchy visualization, where, say in this view here, we sort of have like a box for all the United States states. So each one of these little hexagons in this case, but it could be, usually they're like a square or a rectangle, and these are the different states that you'll see. And so they're encoded by size, and then they're encased within the total number of alerts, say, for the United States. And then that's true for all these other cities and all these other countries. And what we had this thought of was like, well, hey, we could take this tree map approach, which is space filling. It shows this hierarchy of all these locations. And then we could have it we could sort of spatially locate the tree map. So we could then say you have the United States maybe more on like the western side of the world, and then move all of like Europe here more in the middle, and then countries in Asia more on the right side. And there are algorithms that do that, but there wasn't one in D3 that supported that off the bat. And so we thought about implementing that. That was sort of an algorithmic contribution we could have made with the project. But again, after thinking about what were we trying to show, what are the important patterns that are really critical, what we found is that using the tree map was actually kind of challenging. One of the reasons was that because of the way the tree map algorithm works by default is that these, say 1 or 2 or 3 alert countries ended up turning out really small, and they ended up not really showing up because the area gave to them was just too tiny. And you can tweak that, you can make that work, but that was sort of one downside. And the other factor that we had was that larger wasn't necessarily more important. And because of the space filling approach with the tree map, larger just made it seem more important than with this more map-based view. And also, when we showed this to users informally, we found that it was also a little less intuitive for people to really understand what was going on with the tree map. They didn't really understand, these were countries or these were cities until we really had to explain it. Versus when we gave them a map, they knew off the bat what we were showing them, more or less. And so when we were looking at this tree map approach, we had to do this sort of evaluation, this comparison to justify one approach versus the other. And this role of evaluation is really what's really vital here to the nested model. And Tamara refers to this commonly as validation within her model. And again, the goal here is really to try and avoid making ineffective solutions, to justify the ones that work. And there's sort of these threats to validity here on the right side of the screen. Things like you might misunderstand the user's needs if you don't get the right domain abstraction. Or you might show them the wrong thing. Or the way you show it doesn't work. Or that it's just too slow, so they can't get to the actual views they want to see fast enough. And so there's many different ways to measure success, and we'll get back to this later, but some of these ways could be like user feedback, using perceptual principles to pick certain encodings, user metrics or finding adoption rates, and then the algorithmic runtime or complexity of what you're using to run. And so this nested model really provides a good way for you to frame some of your decisions, to decide what to do with your project. But it doesn't really guide you through the visualization design process. It doesn't provide a structured way to go through each one of these steps to actually build a visualization. It's more for thinking about it after the fact or thinking about how you fit into this model. And so we've created the design activity framework as a way to try and focus the design process. So the purpose of the framework here, again, is to guide more problem-driven visualization design work. And the idea is to connect the actions that you take with the decisions you make along the way. So we want to think about this process with respect to the nested model, but a little bit separate, because the way you go about doing this is different. And also to support a very flexible design process. And this is kind of shown from this figure over here, where maybe we have these different stages of some process. And in design, it's often not just one step, step 1, step 2, step 3, and step 4, but it can be a whole mess. It can be a huge spiral, or even a more crazier map than just that. And so it's really challenging to capture this flexible design process. And we created this model after looking at a variety of different design process models in HCI research as well as design research to really try and capture a rich set of things. And the basic tenet of what all this is design artifacts. And so design artifacts are what you create in design. Each one of these has a purpose and is unique. And this can help motivate creation of other artifacts as well. So you can do things like you can record these ideas down on paper or in some code, you can sketch them, you can code them up, and each one of these is different. And you obtain these artifacts through performing design methods. And so examples of some of those design artifacts that we pulled out, that we gathered, was say the personas that I established in this project and I talked about earlier. And so these personas created these artifacts that we had, this sort of representative view of what a user is. And we could refer to those users generally when we talked with other designers, when we talked with other people on this project, and even users to try and get a sense of how well this fit their model. And then another example is doing sketches. And this is really common in design work, is how can we create ideas and capture those ideas? And that's usually using Sketch. And so some examples of these two are on the screen. In the top right, you'll see this sort of map-based view that we originally had in the Sketch. And then this bottom right view is more of this tree map approach, about sort of aggregating that map-based view into more of this hierarchical and space-filling approach of the tree map. And I just want to emphasize that my sketches here are terrible. Anyone can sketch. It's really about capturing the ideas, not about how nice or how pretty it looks. And so each of these design artifacts, there's a whole set of them, and a design activity is where you're working towards a specific set of artifacts. And so each activity, we have 4 of them we've identified, has this different artifact for each one. And so this framework that we've established has 4 main activities. Where this understand activity is about the artifact of design requirements, like the personas we just talked about. And you might see this reference now like in sort of this purple or with a little U to represent the understand activity. Whereas the ideate activity is about sort of capturing ideas. As I just showed you with those sketches, you can again have like these, the ideas are captured or put in some physical form, say through like a sketch. And these ideas, again, I might represent them with pink or with that little symbol I. And then we have the make activity, which is about building prototypes. The artifacts are prototypes. And again, blue or the little symbol M. And then lastly, we have the deploy activity, which is represented with green, the little D. And the artifact here is the visualization system. And that's what you guys will have to build, is some visualization system as your final project. And so I'm going to walk through each one of these design activities. And so for each activity, we've identified a motivation to try and help you figure out where you are in the framework. The motivation can help with that. And so the motivation when you're in the first understand activity is to gather, observe, and research available information to find the needs of the user. And this is what it's about. It's about the user, trying to see who's trying to use this data, why are they trying to use it. And these design requirements, these artifacts, can be broken down into things like opportunities, things that you might be able to build in this space that are new or that haven't been tackled yet or fully supported. Things like constraints or limitations, things that might hold you up or that might have you pick a certain type of data set or a certain type of view to look at that data set. And then considerations, things that maybe are a little bit looser than constraints, but maybe that are sort of important to users. And so for this understand activity, for the cybersecurity dashboard, again, some of the things that we did is very similar to this domain characterization. Oh, and let me hop back here just one second. I have the view of the nested model at the top right. And some of the decisions you'll make in this activity, they can cross-cut both the domain characterization that you might have to perform, but also some of the abstraction that you do. And some of that you guys might not get as much to. I know it's not required for your final project to think as much about the abstraction, but it is a challenging aspect, and I would encourage you to think about, again, what attribute types do you have? How would you represent that data is really critical and contingent upon what your abstractions are. And finding the right tasks are really hard. There's not a really great model out there. Like in Tamara's book, she has a list of some tasks, and I would definitely encourage you to look at that, but it's tough. And I would really like to help as many of you as I can, but limited time, and hopefully if you work with me, we can get successful projects, but abstractions are hard. So for this cybersecurity dashboard project that I worked with, we first read a lot of research papers, and we tried to categorize them and really understand what the field had known about the users, and what did they not know. And there was only even one other paper that we found that even talked about cybersecurity managers. And there's not even any others that studied some of the other personas that we explored. And so that was a huge challenge in trying to understand the space, as we only had limited resources. And so we observed and interviewed a lot of users to try and fill in this space and complete these personas. And that allowed us to filter to a subset of users. So we could say we want to tackle these types of users and these types of tasks. And this high-level goal of communication is also something we teased out in some of the interviews and focusing the project down to a certain subset. And our users even helped us when trying to figure out what the abstraction was. Where they said that, one of them told us, the majority of what we are looking for is patterns. And again, that pattern is the abstraction of what the data type is really about. They want to find this pattern of this alert. They want to be able to see whether it's one anomalous alert or a huge collection of alerts that maybe are occurring in some unique way that might be of interest to them sharing with other people. And so after the understand activity, we have the ideate activity. And so here the artifact is about ideas, about coming up with good ideas. And that's the motivation as well, is to generate good ideas for supporting all the understand artifacts. So for finding out what your users need, what they want to do, what types of data they have, now you need to come up with ways that will then tackle that problem. And so sketches are one of the most commonly formed ways to externalize an idea, where you will take that idea and put it on paper, or maybe put it on a whiteboard, or even write it down on text if you want, to sort of capture what the idea is about. And you can even create things like mock-ups of an interface, or wireframes to represent what the interface will do. And these are all ways to capture some of the ideas that you have. And again, I want to emphasize that anyone can sketch. Sketching is not about an artistic ability. It's just a way to capture an idea that you have. And if you're having trouble articulating that idea, feel free to chat with me when we go through, and I'll chat a little bit about more of some of these techniques I'll give some resources for that when we put together some worksheets, because there's some things about representing people with these little icons and certain ways to represent certain types of things for visualization that might help you if you maybe struggle with starting with a blank slate of paper. And it's really tough. When you're looking at a blank piece of paper, designers and artists struggle all the time. So it can be helpful to start with something that you have. Print out, say, like an interface or something that might give you some inspiration. And we'll come to some methods here at the later that might help you do this process. And also, just to emphasize, this is not about creating a masterpiece. So if you're spending hours on one sketch, on one idea that you're trying to represent, you might be spending too much time. Often what people will do is they'll time themselves here too. Give themselves a minute, 30 seconds to do one quick sketch. Now that's tough. It's very tough. But it is good to push yourself. And then the levels of the nested model that you'll touch on here, again, you'll look at some of the abstraction, trying to figure out what types of data sets you should be looking at and what the tasks should focus on. But then you'll also start to think about how do we then encode some of that data? And then what are the types of interactions I'll want to consider? And so for my cybersecurity dashboard project, one thing we did is we sketched out various forms of the data. I showed you some sketches earlier, but then another thing we did is we created some data sketches. And these data sketches are sort of very rough data prototypes where we wrote some code, very rough, to be able to push the data into a form to say, what if we did this idea? What if we maybe took our data set as a network, and what does it look like? And we created 20 of these different data sketches. And we worked with one analyst here at the University of Utah, and we walked through each one of this. It took like 3 hours to go through each of these ideas, and we got tons of information about different potential patterns, about different ways to look at the data. And for us, it really gave us the most clear encoding we should give the users for this project, for the dashboard. And so one example, which we heard too, was looking at a network graph. What if we just put this on a network graph, we encode all the computers as a node, and then link them together based on who's interacting with whom. And you'll see here just a mess of a network. I don't know if you guys have seen any messy network graphs, but if you have a lot of nodes, it turns into this really quickly. You can add interaction and filtering to help mitigate some of that. And you'll see this is only a snapshot of the whole view up there. That tiny little yellow box is a subset of this graph. And we gave this to the analyst, at least in sort of a text-based form, because that's the way we work with these sketches. And he was just like, this is useless. This means nothing to me. So we didn't spend too much time chatting about these data sketches in particular. But there's still some potential here. It's not worth completely throwing out, but when it comes to communicating the data, this was very abstract. And it didn't mean much. Versus when we gave a map-based view, this was a different type of cartogram where it's now sort of changing the size of a country, sort of making it look weird. And that size then is related to the number of alerts that are occurring along with the color. In this case, actually, it's varied by maybe the number of bytes of the alerts, how big it was, versus how many different computers talk to us from this location, or different ports. And the analyst loved this view. Like, he found so many different patterns, things from countries he wasn't expecting, and he wanted to dig into his data right away. And it's important to emphasize that to create these data sketches, almost all of these, we worked with the analyst's real data to create them. And that's what this is about, is seeing, does an encoding work with the data set that we have? Or does it turn into a mess when you put the data into it? And those are important questions to figure out early, because if you don't figure them out until after you've built the system, you're already limited and you've spent a lot of time implementing something that might not work. So next we have the make activity. And here we are generating prototypes. Those are the artifacts that we want to create. And the motivation is to take your ideas and concretize them, just make them more complete with tangible prototypes. And here we define prototypes as being approximations of a product along some dimensions of interest. And this dimensions of interest is where it gets a little bit fuzzy, because you can have artifacts that are lower to higher fidelity. And this kind of usually varies over time. And so this lower fidelity prototype might be something that I even just showed, where those data sketches could be an example of a low fidelity prototype if maybe your goal was to take that idea and keep flushing it out. But we were more looking to evaluate ideas, not to create a prototype. And for visualization, you often build these using code, and they tend to be a little bit more on the higher fidelity side. But I would encourage you to think about, shooting for that lower fidelity to first see what works best and evaluate it if possible. And in terms of the nested model, this touches on the encoding interaction idioms that you want to support and build in your tool, as well as the algorithms that will help you create those. Especially when it comes to building prototypes, you need to start thinking about what algorithms you need to do to create those prototypes and get them at least to a working point where you could evaluate them, or you can say whether this is the right idea that we should keep building out. And then for this activity, oh yeah, was there a question?
No.
Oh, okay, sorry. And then for the cybersecurity dashboard, for this project, when we were building a prototype, I showed an example of one of those prototypes that we created over there. And we built our first prototype using that tree map view that I showed you earlier. And after evaluating that as an idea, we switched to this map-based view you see here on the screen. And then we built this map-based dashboard. This was an early prototype of this system. And we evaluated this with users anecdotally to see how they used it, and in a usability study. And then to answer the question earlier, this usability study is where we were first showing analysts this dashboard as well as managers, explaining how they could understand the encoding. And what we found is after giving them the system and explaining that within less than 5 minutes, everyone kind of understood what we were showing them in the data. So it seemed like people were able to pick up on the dashboard with very little formal training that we had. And just by interacting with it, they found the most benefit, because just seeing it wasn't as useful to be able to then interacting with it. And this usability study that we performed was using a specific scale that just has 10 questions and ranks out of 10. So the bar chart you see on the top there is where we ranked each user based on their score. One user was really harsh, but everyone else was more or less above this little green line, which is what they call an average usable system. And on average, we were better than an average usable system. And that was sort of a way to say, how good is this prototype in terms of, frustrated users, upsetting them? Does it match their expectations or how they would expect to be able to interact with this data? And anecdotally, we heard things from users such as like, this dashboard is very responsive and dynamic, and the fact that it changes as I narrow in is really best. And that I can write a query to do this, but this dashboard is just easier. And then lastly, for the deploy activity, our motivation here is to bring a prototype into effective action in a real-world setting in order to support the target user's work and goals. And so here it's more software engineering related decisions that you might make, thinking about making the tool usable and then fitting it into the user's workflow. And you might have to optimize algorithms to really increase the interactivity and the speed of what you're doing. And that's again, tomorrow's nested model, the algorithm level is what's most important. And so briefly for sort of this dashboard project, we showcased our prototype that I talked about, that map view to other people, and there were certain benefits, things they liked about it. And so they took an existing system that they had and started adapting some of the principles into sort of this already deployed system that they had. So things like the map view, some of the interactions were incorporated into this view. And then for this design activity framework, we've also come up with these design worksheets to help structure the design process. And so each of these worksheets is for each of these activities, and they help you capture design artifacts and your goals on paper. And this structuring the design process is really what we're trying to do, is help people who are still newer to visualization design really understand what the design process is about. And for the design process, just to kind of briefly mention this flexibility, this messiness that we have, is that the forward movement here is always ordered. You always go forward. But when you go backward, you can go back to any activity. And in addition, this is a subtle point, but that activities can also be done in parallel or nested. And this kind of leads into this notion of an iterative process, which I won't go too much into, but it's just that these four levels of the nested model, the 4 levels of the nested model, as well as the 4 activities that we have, they rarely occur in order. They usually look messy, where maybe like over time they'll look something like this in a more finalized project. And so just don't limit yourself to a specific activity. Think about where you really should be and where you want to go next. And then lastly, we have design methods. And we've talked about a variety of design methods so far, some that are generative about creating artifacts, like these interviews, these personas, and the data sketches, but then also some that are evaluative, where we use these personas to kind of figure out which users to target, and then which data sketches to, we use that as a way to evaluate which ideas to pick, and then that usability set. But there's other methods that are out there as well. And so one such method is parallel prototyping. And there's a really great paper on this. I would definitely encourage you to look at that. But it's this idea of trying to understand, what if we create things rather than all at once? If we kind of have multiple ideas and try them out. So there was a user study here in HCI on graphic web design, looking at serial web design of an ad, where you would create one idea, get some feedback, create a new ad, and so forth. And you'll see that those ideas were often the same. And there's a lot of benefits, whereas if you design in parallel, create 3 ideas, get feedback on each one separately, create 2 new ones. And what they found is that people who created this design ads in parallel were getting more clicks, finding more people on their site, getting better ratings, and just people were feeling more confident about their designs. So creating multiple designs at once, multiple ideas, trying them out can really benefit design, potentially.
That's interesting to me, thinking about the different stages in your design process at which to get feedback, because you can get feedback on a sketch, a feedback on a prototype. Like you made tried 20 different visual encodings of the data, and it's just interesting. Like not every one of those might necessarily be
right. And there's always time factors as well that'll limit you based on how many you can explore.
Right.
But I would definitely encourage more, because it's at least one way has been proven to show potentially more. But there's other methods as well. One such method is these 5 design sheets. And I won't go too much into detail here, but I would just encourage you to take a look at this resource if you want to help find a way to design your visualization system. So once you know what you want to design and what encodings you might want to pick, or maybe you still want to play with some of those ideas, these sheets can help you. But our sheets are going to be better. I'm just teasing, but this is another thing that I would consider you to look at as well. Another cool idea, if we could pass out some of these cards here. So there's this idea of these visit cards. It's actually really new. This was published at the IEEE Viz conference this year. And these are different cards that assist you with visualization design. And you can find these all online, and there's different types of cards that they've created. These were sort of tailored for more of a classroom setting. And they have cards that will talk about the domain, as well as what type of tasks, what type of data you might want to look at. It's more specific to a certain exercise, as well as inspiration cards that will look at certain existing tools that are out there and existing visualizations to give you some inspiration. They also have gestalt principles as a way to motivate some of your decisions. And they talk about some abstraction and some layouts there. So feel free to take a look at some of the cards and just pass them around. I'll have them in here as well afterwards, or you can find them all on their website if you want to look at that more. And the goal is to help students design, compare, collaborate, apply, and synthesize what they've learned. And so feel free to just keep passing those cards around the classroom, and I'll just continue on. And so lastly, I just wanted to wrap up with the final project, talking a little bit about what I'm going to be doing and how I can help you guys with your projects if you're interested. So first is the role of these worksheets. So we're also going to pass around some worksheets, examples here. So these here are about the Design Spree framework, where there's sort of a cover sheet that's an introduction to the framework. And then there's 4 more sheets. So I talked about these briefly earlier. And each of these sheets is about a single activity. And, we just wanted to kind of get this out to you guys. If you want to take a look at it, again, chat with me afterwards if you want to find out more. But the idea is to help you structure the design process, to find the artifacts you want to create, to make more effective designs, and then also to reflect on this process and think about what it would look like. And so we're going to encourage this for the class to use, and we're going to, again, contact me if you have questions or need assistance with your projects, framing them, figuring out what you want to design. And we're also planning to conduct a survey at the end of the class, and then potentially some interviews if people are interested to kind of chat a bit about, what you might change, what you thought worked well, what didn't work as well. And so for these worksheets, we're going to revisit these in another class period just to kind of give you an example of one, have you walk through one with a partner, and just kind of think about the design process from a more structured, with a focus point of view, like say an exercise, a design critique in the class. And then at that time, we'll have links for this instructional sheet and the worksheets provided to the whole class as well. And just as a reminder, remember to contact me if you'd like to have me advise your group's project. It's a first come, first served basis. There's limited space. It's going to fill up. And the TAs, otherwise, if you don't pick me as an advisor, all the other TAs will just be assigned randomly to your final projects. And you can email me for more information or find out more on my website. So thanks everyone for listening on visualization design, and I hope I can help you be more effective. So yeah, and if you'd like to see those worksheets when you're done, I can take them, or people who want to see them can stick around. Thanks.
Thanks, Sean.
Yeah.